In this video, we'll be learning how to state the domain of a function by simply looking at the equation. So just to refresh your memory, the domain is basically the set of all of the input values or the x values that a function can take in. And when we've seen these on graphs, because typically we've been identifying domain and range with graphs, when we've seen these on graphs, we typically can write something like all real numbers, because maybe the graph is going forever to the left and forever to the right. Or when we had, square root graphs that had like an endpoint, sometimes we had a domain that looked like something like x is greater than or equal to, -2. These are just examples of what your domain might look like and examples of domains that we've encountered in this class. So the big thing that we have to learn is how do we determine when we have a domain that is all real numbers? And then how do we determine if we have a domain that is something else? And how do we basically identify that something else is going on? So what I like to think about is the situations where the domain might not be all real numbers. Because most of the time when we see a domain, a good chunk of the time it is all real numbers. So I like to think of situations where maybe you have a restricted domain where, there's x values that definitely won't work. And when I start to think about that, I think about things like even roots. When we have an even root, so say we have like the square root of x minus 2. I know that there's some restrictions on this function because the inside of this function cannot be negative. I know that x minus 2, in order to work with an even root, has to be greater than or equal to 0. So I know that there are some restrictions there, and just by knowing that the inside of that root can't be negative, I can set what the inside of that root is greater than or equal to 0 because that's what it has to be. If I then add 2 to each side, I find that my domain is x is greater than or equal to 2. So this is a situation when we have an even root that we're going to have a restricted domain because the inside of an even root cannot be a negative number. Another situation that we commonly encounter where we might have a restricted domain is when we have an x value in our denominator. That's another situation that we commonly see. So say we had something like, the equation x minus 2 over x plus 4. What we know about fractions is that the denominator of a fraction can never be equal to 0. It can be positive, it can be negative, but the denominator here can never equal 0. So we're going to basically figure out, okay, what value of x makes the denominator equal 0, because that's the only domain value that we can't use. And so if we solve this little mini equation here, we find x is equal to -4. So in this case, our domain would be all real numbers. And then basically we would state, but x cannot equal -4. Like that's our one restriction because that denominator can't be 0. Otherwise, any value works for x. So most of the time we're going to see a lot of all real numbers, but if we have things like even roots or an x in our denominator, we're going to have situations where we have a restricted domain and our domain is going to be slightly different. So let's take a look at a couple of different examples here. First, I notice in example 1 that we don't have any of those situations like an even root or an x in the denominator. And as a result, all I need to do for any of those other situations is state that my domain is all real numbers. Because I don't have any of those special situations where x is restricted, x can be anything. I can put any number I want here in for x, and it will produce a function value. If I then look here at example 2, I notice that I have a fraction with x in the denominator. So here I have a denominator with x minus 2, and so I know that the denominator can take in anything except for the value that makes the denominator x minus 2 equal 0. So if I solve that little equation here, I find that my domain is all real numbers except x equals 2. Or you could write something just like x does not equal 2. But our domain here are all of the real numbers except x equals 2. It's the only one that will not work. Then if I look at example 3, I notice that I have an even root. So I know that the inside of this root has to be greater than or equal to 0. It can never be negative. So I have 3x minus 4 is greater than or equal to 0. So I end up with 3x is greater than or equal to 4. And so x is greater than or equal to 4/3. So my domain here consists of all of the x values that are greater than or equal to 4/3. And then this final example here, I notice that I do in fact have a root, but it's an odd root. And an odd root can take in positive, negative, or 0 numbers. And as a result, I don't have any restrictions, so my domain here is all real numbers.